Good morning, everyone. Thank you to the organizers to giving me the opportunity to present here today. So, as you can hear, I'm going to present in English, and I will do the first part of the upcoming hour, and Federica Carta will do the second part. So, to start with, I'm going to introduce the easy-to-use quality label, the background, the efforts behind this label, and the contribution to a more sustainable beverage industry by Fermentis. And in the beginning, I'm going to give you some elements on the improvements, the concept behind the easy-to-use, and some related also corporate responsibility elements that can be associated with the labels and the products. I will give you also some tools to understand the evaluation process of the easy-to-use products from the Fermentis range, and in the second part, Federica is going to develop more the technical performance of some specific easy-to-use active dry yeast in winemaking conditions. So for those of you that are unfamiliar with Fermentis, it is a branch that is entirely dedicated to the fermented beverages, so winemaking, but other fermented beverages as well. It's a branch of the French family-owned company Lesaffre, which is a yeast producer established in 1854. So this is to give you an idea about the background of the brand. And now when it comes to the specific part of the easy-to-use quality label, the idea behind this is to be aligned with the demands of our customers in diverse fields of fermented beverages, winemaking being one of them. And the idea behind this is to guarantee an improved technical performance, first of all, but also associated with an economic promise, contribution to the protection of environmental sources to some extent, and foremost, the comfort and ease and safety of the users. So what is the easy-to-use concept? The easy-to-use concept involves both active dry yeast and also yeast derivatives. So when it comes to the active dry yeast, the idea is to give a flexibility to end users, to winemakers, to all people handling the yeast in the cellars, by giving them the flexibility to choose whether or not they want to rehydrate the yeast before inoculation or not, or if they choose to direct inoculate without rehydration, and with the benefits that are associated with such a practice. When it comes to the yeast derivatives, two criteria have been invested. It's improved dispersibility of the yeast derivatives and also an improved pulverescence. It's the same concept as dustiness. So I will get more into details on the evaluation of these criteria a bit later during the presentation. But all in all, these are the basis of the easy-to-use quality label, and there has been a lot of efforts put into this for improving the product quality foremost, and to start with, through the use of advanced Lesaffre technologies related to the stabilization, drying, packaging, and other steps of the process. So in addition to the technical improved performance of the easy-to-use products, additional objectives have been, again, to align with customer needs in terms of sustainability from an environmental, societal, and economic perspective. So, in addition to the improved ease and safety of users, reduction of costs also that can be related, the idea behind is also to be reducing pollution and protect natural resources. So if we go back in time to give you some ideas about the background of the easy-to-use product, the first reference was launched in 2012, so 10 years ago. And the first product was then put into application. The brand itself, as you can see here, the brand for communication purposes, was created in 2015. and it was assigned to the product vini liquid, which is liquid nutrition, which is yeast autolyse based, and then to spring finer, which is a yeast protein extract for fining purposes, and then throughout the years to a numerous amount of products involving the active dry yeast, but also other yeast survey-based products. So you can see until today, including other fermented beverage portfolios, such as also brewing, over 90% of the Fermentis yeast and derivative range is certified easy to use. So what are the impacts from an environmental point of view? The fact that the easy to use products do respect the criteria I mentioned earlier will lead to the reduction of water consumption, detergent consumption, and also energy consumption, leading all to a better conservation of resources and protecting the environment. And of course, this is all associated also to the ease and improved application of the products, technically speaking. So from a safety, social, and economic point of view, the easy-to-use products, they reduce the risk that can be associated with the inhalation of fine powder. Of course, the yeast in itself is not a dangerous product, but I'm sure that all of you that have handled such products in the cellar know how uncomfortable it can be, and creating, in some cases, some reactions that are can be quite uncomfortable. So the improved I would say nature and the form of the product will reduce this risk. The comfort and ease of use, from handling the packaging to introducing the product into the environment, is a very strong key element, I would say. It will definitely make it much easier for people handling the products in the cellars to be more performant, more efficient, using less time to the handling of the products, which also will lead to reduced investment in terms of personnel, in terms of time invested, and also the risk that can be associated, especially with the active dry yeast, when it comes to the rehydration. It reduces, among others, also the risk of cross-contaminations, less handling of rehydration vessels and other equipment in the cellar. And also, if we think about reducing investment, the introduction, direct inoculation of highly performant and robust yeast will also reduce the investment in other products, such as rehydration products. So it's also economically interesting in that sense. So all in all, increasing the performance of the products will also lead to consistency, reliability, and also transport rationalization when it comes to that part. So just to finish on this part, going a bit further, in addition to these three key concepts related to the social or corporate responsibilities, at the current time, Fermentis and Lesaffre are putting also efforts into improving the storage of the products at room temperature, and reducing the use of inert gas consumption in product processing, packaging, and also one of the main focuses is the reduction of waste and packaging by implementing new packaging materials, types, making it also, in some cases, possible to supply smaller users in bulk in order to reduce waste. So, now, getting a bit more into the performance and the process and technical aspects behind the products, I'm going to show you the criteria that we associate to the different segments, active dry yeast and yeast derivatives. So for the active dry yeast, there are three criteria that are evaluated and with specific values that have to be respected. So one of the first criteria is high viability. So what we do is to rehydrate the dried product in water at different temperature, as you can see here, ranging from 10 to 43, with different levels of osmotic pressure, in some cases with medium or high sugar concentrations to also see the reactions of any improvement or change when conditions are modified in this sense. And as you can see, the viability of the rehydrate product are above 80%. For some specific products, we can go much higher, over 90 or even 95%. And this is an extremely high viability ratio. So this is one of the criteria that has to be respected. A second one is that no matter what type of preparation the yeast are submitted to, the fermentation performance has to be similar. If it's not, then the product will not be qualified easy to use. So whether it be the standard rehydration process that is used to the products or just rehydration in pure water at cooler temperatures than the standard rehydration temperatures that are recommended, meaning 15 to 17 degrees, which is quite close to tap water temperatures, or direct inoculation, the performance in terms of kinetics has to remain quite similar. The third criteria evaluated and that needs to be respected is the sensory profile. So wines are produced and through triangular tasting evaluated by trained panels to see if there is any significant difference or not. So in terms of sensory profile, the outcome has also to be guaranteed to be quite similar. When it comes to the active dry yeast, this is a two-step evaluation. One of the first criteria involves pulverescence or dustiness. In this case, we do evaluate the particle size distribution through a measurement with a laser granulometer. So the dustiness of a powder is defined by the median diameter of the particle, as you can see here, and the span. It measures actually the shape of the particle distribution in a medium. So the criteria that have to be met to certify a product easy to use for the yeast derivatives is a very high median diameter, so big particles, and also a span that is quite small, beneath 1.5. So to give you some specific examples and also pictures to illustrate this, here you can see a product, a spring cell color G2 for color stabilization, and the measurements of median diameter for both fine powder and microgranulated powder, which is a bigger size. You can see that the median diameter is above 100 micron, but when it comes to the span, there is a difference. There's a big difference, actually. You can see it on the shape of the particle size distribution graphs here below, and also on the image. So the criteria that has to be met has to be close to this shape of the graph. And you can also see that on the picture we don't have the same shape of the particles. So it makes the big difference when it comes to the dispersibility also in a liquid afterwards. The second step is to verify that the powder is homogeneously spread around in the liquid and that we reach complete homogeneity within 3 minutes in a liquid that is under moderate stirring and a maximum temperature of 20 degrees. So just to give you also here some examples throughout a set of photos, you can see the same product again, the spring cell colored G2. On your left you have the fine powder without and with stirring, and on the right you have the microgranulated form without and with stirring. So clearly you don't have any formation of lumps, and the product distributes homogeneously under stirring much faster than the one that is in micro or in fine powder form. So to conclude on this part, before giving the microphone to Federica. We have another product in the yeast derivate portfolio, the vini liquid, which is not exactly, it doesn't have to meet the same criteria as the other yeast derivatives, because we're talking about a liquid product here. It is just to say that the ease of use of the product is guaranteed, and in this case, one of the advantages that we have also identified is that once you have such, I would say, products at hand, it can also lead to new opportunities of associating products with technology. And one example is a collaboration with one of our major distributors here in Italy, HTS or HTS, as you say in Italian, to develop and implement different tools. To start with, it was the Bionica, and later on Avaferm. That has allowed us also throughout time to measure the product performance and to, at the same time, while preserving the microbiological quality of the product, and through the results obtained, improve also the technology and the product performance, and this is a huge advantage also in these cases. So all in all, when it comes to the improvement steps and development of more performant product throughout the years, we have worked hand in hand with several partners. During development collaborations with different Lesaffre partners, having a high level of expertise in processing and production, and also scientific partners. And here you can see some we have collaborated with in France, among others, for that purpose. INRA, Vivelis, Laboratoire du Bernay. And when it comes to the application collaborations, we have numerous other partners also. And one of the real advantages that have come out of these partnerships is, among others, when it comes to the production of the active dry yeast, the obtention and implementation of a multi-effect drying tower that makes it possible today to obtain the easy-to-use qualified products for specific purposes during winemaking. So in the next part, Frédérica Carta from Laboratoire du Bernay is going to highlight some of the product performances in the winemaking conditions. Thank you.
Per controllare la presentazione. Buongiorno a tutti, grazie.
Hello everyone, and thank you, Mariam. Despite I've been working, the fact that I've been working in France for over 11 years, I still have a thick accent. I represent the Dubernay laboratory in the Rhone area, which is now regarded as one of the largest independent labs in all of Europe. Just a couple of words to describe the company I work for. The Dubernay laboratory, or Laboratoire du Bernay, has dealt with innovation in the winemaking world and analysis for 4 generations. We're specialized in wine analysis, chemical, physical, chemical, microbiological, agronomic analysis, and soil analysis. And generally, we accompany our clients in audits and result interpretation, and also to improve growing techniques. We've carried out a study to study the behavior of 2 specific yeasts of the Fermentis range, Safeno HD T18 and Safeno HD A54, to test their rehydration and their effectiveness in alcoholic fermentation in terms of microbiological viability and sensory results. We've cooperated with the INRA, Institute of Pêche Rouge, and we studied a Viognier from southern France, from Languedoc-Roussillon. The vintage, the harvest year was 2020. We used a T8 with a fermentation at 18 degrees on a volume of 50 liters, 20 grams per hectoliter. We used an automatic press, 30 hectoliters of capacity, and we added 3 grams per hectoliter of SO2. Now, at that point, we assessed the effectiveness on alcoholic fermentation based on different ways of rehydrating the yeast. So the first rehydration took place in warm water, 20 minutes at 37 degrees with an acclimatization to must temperature. Then we studied a rehydration in cold water, 18 to 20 degrees without acclimatization. And the third mode was the easy-to-use direct addition to the must. Easy to use yeast directly to the must. 50 grams hectoliters of DAP were added to make sure that the fermentation would be concluded problem-free. Now, the basic must. In 2020, musts in France lacked nitrogen. The level here is 94 milligrams per liter. The other characteristic of the 2020 millésime was the presence of a high microbial load from the beginning. We went for an initial microbiological study to assess the concentration of yeast in the must. It's 10 to the 8th. We've checked how many of these yeasts belonged to the Saccharomyces cerevisiae family, and over 90% belonged to that family. And then later on, we checked how many strains belonging to HDT8 were part of that 90%, and we assessed that the HDT18 was above 90%, so the yeasts were well integrated regardless of the rehydration technique. In terms of the fermentation kinetics, we tried to control the fermentation from a temperature perspective, and we monitored the temperature for all 3 modes throughout the fermentation, and no significant difference was recorded. We didn't even find significant differences when we checked the microbiological population throughout the alcoholic fermentation. The trend is the same, as you can see, for both warm water rehydration, cold water rehydration, or direct addition. We also analyzed the thickness, the density of fermentation on a daily basis, and the figures here, the readings, are very similar. On day 13 of the fermentation, the residual sugar was more or less at the same level, so the fermentation kinetics was more or less the same. No significant differences were found. At the end of the fermentation, we also analyzed the fluid. There are no analytical differences because alcohol stands at 12.8 to 12.9, so we didn't find major differences. So we went for an assessment of the aromatic compounds to see if there were any organoleptic or sensory differences. We tested acetaldehyde, ethyl acetate, methanol, isobutyl acetate, ethyl butyrate, propanol, and isobutanol without finding any specific differences. Also, isoamyl acetate, isoamyl alcohol, ethyl hexanoate, hexyl acetate, ethyl octanoate, ethyl decanoate, the results were in line. Then finally, we organized a test panel with 6 winemaker enologists who work at our labs to see if there was any real difference between the different ways in which the yeast had been rehydrated in in warm or cold water, we compared also warm water, no rehydration, and cold water, no rehydration. 1 out of 6 said there was a difference, but statistically none was found. So the conclusion for the first test was that in terms of fermentation performance, HDT18 was successful in all three modes. The fermentation kinetics was identical, and when it comes to the analytical profiles, no significant differences were found either in the wine analysis data nor in terms of aromatic compounds. So from a sensory perspective, no significant differences were found. Now, as for the second test that we carried out, that was carried out using HDA54. We went to a different varietal, Macabeo, also from Languedoc-Roussillon in southern France. Same vintage, same harvest year, 2020, 20 grams per hectoliter. The fermentation temperature was 16 degrees C, the volume 80 liters, automatic press, 3 grams per hectoliter of SO2 at the press. In this case, we used 4 different ways of rehydrating the yeast. We directly inoculated at 10 degrees. We inoculated directly at 16 degrees without rehydrating in either case. And then we rehydrated at 18 degrees. And then we rehydrated with an acclimatization at 16 degrees. Again, 50 grams hectoliter of DAP, 1/3 through the fermentation. So we stressed it a bit. We stretched the use of the yeast a bit. Now the must, as previously, had low nitrogen levels and a high microbial load at the beginning. In this case, again, we carried out microbiological analysis to test the concentration of yeast in the must. Again, it's 10 to the 8th. And based on this, we tried to understand how many yeasts were part of the S. cerevisiae family. We stand at 95%, as you can observe. And out of that 95%, in direct addition, 100% would be HDA 54. When it comes to the last 2 modes of addition with acclimatization under warm and cold conditions, 4 different strains were identified. So in the former case, 40% of prevalence. In the second case, 10% prevalence for our yeast. Again, the fermentation kinetics were studied, but it's different this time. In mode 5 and 6, the green one and the blue one, the kinetics is different from the 6 and 7, 7 and 8, the ones in yellow and dark green. This also had an impact on the final analytical data at the end of fermentation. There's a difference in volatile acidity, which escalated to 0.37 and 0.45. Which is in line with the fact, which is consistent with the fact that there were 4 different strains during the fermentation, and also ethanol went up. Here we studied the aromatic components or compounds. In the case of ethyl butanoate, so mode 5 and 6 are different from 7 and 8, and there is a significant difference. That is not the case with ethyl octanoate or decanoate, but we find another difference in terms of the ethyl lezanoate. Another significant difference was found in the case of isoamyl acetate, because as you can tell in this case, the no hydration mode, the green, light green and blue are different from the yellow and dark green modes. Conclusions. Unlike in test number 1, in this case, we noticed significant differences in the direct inoculation of the yeast and the fermentation kinetics. In terms of the analysis, significant differences were found in the wine analysis and also when the aromatic compounds were studied. Our conclusion was that from a sensory perspective, after a tasting carried out by a panel of 6 enologists, the differences were significant. Of course, the interest of using a yeast of this kind that can be directly inoculated without being rehydrated is characterized by a number of pluses. This yeast, when used in the winery, will prevent us from having to dedicate a worker to rehydrating the yeast. There is a possibility to inoculate without water. You save time and energy. And you don't have any sensory deviations because of the presence of other yeast. The fermentation kinetics is the same. Thank you very much.